Hi, I'm an old guy and I do maths. I got asked the other day to explain to a student of mine what a residual was, and I thought it would make a good topic for a video, so here we are. I'm going to attempt to explain residuals. Now, this falls into the subject of linear regression, and it's in the area where people are trying to approximate a relationship between an x-axis value and a y-axis value, where you have scatter plots where all the dots don't line up, as they say, and it's associated with lines of best fit, which I think should probably be a topic of another video. Anyway, let's get into residuals. So what we have here is an illustration, a very simple illustration of a scatter plot. Now it's a pretty sparse scatter plot, but it's useful for explaining what residuals are. And we have here a line of best fit, and this will have some sort of equation, something in the way of y equals mx plus c, or y equals a plus bx, whichever one of those you use. And it's most likely been found by using a calculator, although there are manual ways of finding a line of best fit. And again, we might go into those at a later date. Anyway, we have our line of best fit, and the actual data that we have gives us a point here, a point here, and a point here. And this may sound ridiculous, but please note that this point is above this line and some distance from it. This point is on the line, and this point is below the line and some distance from it. Now, the residual value is the distance between here and here. The distance between here and the line, which in this case is 0. That's very easy to calculate. There is no distance between these two because this is on the line. And the other residual value that is not 0 is this one. And it is the distance between this point, which is an actual value, and the equivalent point on this line, which is a predicted value. Now, how we get a predicted value is we take the x value here and we put it into whatever equation we have that generates this line, and it gives us a value here, a y value here. And the residual is the difference between this and this. It is the difference, speaking in strict terms, it's the difference between the actual value, which is this point here, which is the observed piece of data, and this point here. So it is this y value minus that y value. In this case, it is this y value minus the y value here, which I have unhelpfully marked with an x, but this value here is y, this value here is y. We're looking for these values here, and we're comparing them with what we actually got. So the formula as such for this is that the residual, which I can't spell by the look of it, residual is equal to the actual value minus the predicted value. Predicted values are always on the line. The residual value of this will be positive because it is the actual value minus that, and this is less than that. And the residual value here will be negative because it is the actual value minus the predicted value. So you can tell if the number that you get has a negative in front of it, your data point, your actual data point, was below the line of best fit. That's all there is to it. It is this distance here. And we find that distance by taking the difference between an actual and a predicted value. Okay, I hope this was helpful, and I hope it cleared up some misconceptions or misunderstandings that you had. If you found it useful, please subscribe, and I will see you next time. Bye.